Okay, students. So here if we see z is equals to I, so that argument z, we write it as 0. So we have seen modulus amplitude forms of these four. So and for z is equals to minus I, it will be cos minus pi by 2 plus I sin minus pi by 2. So we can write it as 0 minus I, and cos pi by 2 is equals to 0. So it is cos pi by 2 minus I sin pi by 2. So these are the four mod amplitude forms for the basic things we have to remember. When z is purely real, either plus or minus 1, and when z is purely imaginary, plus or minus I, you have to remember these four. These four are not usually you have to use to solve some of the questions. So these four are very important to remember. Now let us see another question. Up to these questions we have discussed in the previous class. Let us suppose this is one of the important question, one of the important models. Real part of z plus 1 by z plus I is given. Then what will be the locus of this z? So again, to find the locus of z, we have to take z is equal to x plus I1, and then reduce into the, then find out the real part. So that if you write z is equal to x plus iy, given expression in the form of x plus iy, we can find the real part. Now here the expression is z plus 1 by z plus I, but z is equal to x plus iy we can write. So that x plus iy plus 1 by x plus iy, plus I, it should be, this should be plus I. So we get this x plus 1 plus iy by x plus y plus 1 into I. Again, taking the conjugate of the numerator, conjugate of the denominator, x minus y plus 1i, x minus 1 into y plus I, and simplifying, we get to the x plus iy form for z plus 1 by z plus I. So upon simplification and writing, we get this form. So hope all of you clear with the calculation part. So upon simplification, the numerator will be x square plus x plus y square plus y plus I into xy minus xy minus x minus y we get. So upon simplification, we get it to be, by writing separating the numerator and the denominator, we get it to x square plus y square plus x plus y by x square plus 1 y plus 1 whole square. So we require real part. So I did not bother about the imaginary part. So we did not simplify the imaginary part. Now real part of z plus 1 by z plus I is equals to 1. That means the real part, if you consider x square plus y square plus x plus y by x square plus y plus 1 whole square is the real part. So which is equals to 1. Now upon taking cross multiplication, we get x square plus y square plus x plus y is equal to x square plus y plus 1 whole square. So upon simplification and cancellation of the terms, we get it to x plus y is equal to 1 plus 2y. So upon simplification, x plus y minus 1 is equals to 0. So the locus of z is a straight line given by the equation x minus y minus 1 is equal to 0. So hope all of you are clear with this question. So whenever the question is given, we need to identify what is to be done. Here, real part is asked. Given expression, we have to find the real part. That means the given number should be written in the form of x plus iy form, so that we can easily identify the real part. Let us see one more question. Here, this is one of the important questions, definitely asked for 4 marks. And there are 3 or 4 questions in the exercise. So out of which I have discussed a few. One of the important models also. So if z is equal to x plus iy, and if the point P in the argand plane represents z, then describe geometrically the locus of P satisfying the given equation. The first equation is modulus 2z minus 3 is equals to 7. Here z is equal to x plus iy is given, and you need to find the locus satisfying the given condition. So mod 2z minus 3 is equal to 7. So we have defined modulus of z as root over x square plus y square. But what about modulus of 2z minus 3? So first of all, you should write it in the form of x plus iy form. Then only you can find the modulus. So here z is equal to x plus iy and mod 2z minus 3 is equal to 7. So 2z minus 3 will be in the form we have to expand. So if you write 2z minus 3, it will be 2x minus 3 plus iy. So upon expression, so 2x minus 3 plus 2yi, it will be 2z minus 3. So modulus of this will be root over x square plus y square. That means root over 2x minus 3 whole square plus 2y whole square is equals to 7. Since modulus of z, if z is equal to x plus iy, we have mod z is equal to root over x square plus y square. But here modulus 2z minus 3 here is 2x minus 3 plus 2y minus I. Therefore modulus of this 2z minus 3 will be root over 2x minus 3 whole square plus 2y whole square. So upon simplification and expansion, we get the locus. From here, it is all again your lower class part. You have this. You have did the simplification in class 10 as well, and in the first year Locus chapter also you did the simplifications. Up to this part only it is complex numbers. From here it is all known for you. This is all your previous simplification of Locus chapter only. So Locus chapter is integrated with complex numbers. That is why whenever you get an application questions connecting one chapter to the other, those kind of questions are very much important. So it connects the complex numbers with the Locus chapter. So upon simplification, we get x square minus y square minus 3x minus 10 is equals to 0. Hope you all know the calculation part and simplification. That is why I am just showing it. Now, if you see what will be the locus here, can you guess what kind of equation is this? This, if you see, it is in the form of x square plus y square plus 2gx plus 2fy where f is equal to 0 here, 2fy plus c is equal to 0. What will be this equation? This is the equation of circle with center minus g minus f. So here the center is minus 3 by 2. Center is 3 by 2 0 and with a certain radius. Therefore, the locus is a circle. Equation of a circle represents the circle, and the equation of the circle is x square plus y square minus 3x minus 4. So let us move on to the another question. Finding the locus of z satisfying the given condition mod z plus 4i plus mod z minus 4i is equals to 10. So here it is one more important question. This question particularly 1C exercise Roman number 2, 3-2. Question number 3, Roman number 2. So this is one of the important questions for 4 marks. So as if you see mod z plus 4i plus mod z minus 4i is equals to 10. So first of all we need to write down what is z and z minus 4i, so that we can write modulus z plus 4i and z minus 4i. So let us take z is equal to x plus iy as it is given in the question. And we find out first of all we write first of all z plus 4i and z minus 4i. So z plus 4i, it will be x plus I into y plus 4, and z minus 4i is x plus I into y minus 4. And the modulus is root over x square plus y square. Modulus of z is root over x square plus y square. Therefore, we can write it as root over x square plus y plus 4 whole square plus root over x square plus y minus 4 whole square is equal to 10. Now, if you see this, the same kind of question you have solved in Locus PA plus PB is equals to 8 plus or minus 8, something will be there. So the technique what you have used in solving that particular question, we have to use the same technique here as well. PA plus PB is equal to plus or minus 8 question will be there. It is a particular method. So you have to follow the same way. Now we can write it as, we write one square root on the other side, so that it will be easy to simplify. Otherwise we cannot eliminate the square roots. Unless otherwise you write, suppose if this is PA plus PB is equals to 10, if you take, you have to write it as either PA or PB equals to 10 minus PB, or if you're writing PB, you should write 10 minus PA. Otherwise, you cannot simplify this. You cannot eliminate the square roots. So this is a particular method. Remember the technique. So we should write it as a 10 minus of PB, which is equal to root over x square plus y minus 4 whole square. And from here, the remaining part you know, to simplify as it is all previous part only. So upon simplification, we get it to be y plus 4 whole square plus y minus 4 whole square is equal to 100 minus 20 root x square plus y minus 4 whole square. If you see it again, it is 16y minus 100, which is equal to minus 20. So upon writing, upon simplifying this, we can eliminate the square root so that we can find the locus of z. So upon simplification, squaring on both as here we can simplify with this expression, as 4 is the common factor of all, we can cancel out 4 throughout, so that it will be 4y minus 25 is equal to minus 5 root x square plus y minus 4 whole square, so that we can simplify it to expand and simplify, so that we get the equation 25x square plus 25y square minus 16y square minus 625 plus 400 is equal to 0. So upon simplification, we get it as 25x square plus 9y square minus 225 is equals to 0. If you see, this is, yeah. Yeah, here coefficient of x square and coefficient of y square are not equal. So this is not circle. So we will discuss the type of conics in the after the circles chapter. We will discuss. Okay, students. So these are the major questions which are for 4 marks and 2 marks based on modulus and amplitude form. Okay, students. So if you have any doubts, we can discuss upon this. Sir, I will stop my screen sharing. So the locus is the equation of a conic. If I have mentioned it circle, then it is wrong.
Students, if you have any doubts, just unmute and ask your doubt if you have any.
Yeah, this is the part up to for today, and we will discuss remaining questions in the next session. So here I am going to end up my presentation.
Students may ask your doubts.
Students, we will going to close the session by 11:20. So you have 10 minutes time to ask. If you have any doubts, we will move on. Otherwise, we will carry on with the doubt session. The students are requesting for annotation. I don't understand why you want to annotate.
So somebody named Sharda raised the hand.
Yes, sir.
Hello.
Yes, Chapma.
Sir, amplitude form lo చెప్పారు కదా సార్ modulus amplitude
అవునమ్మా. అవును.
operation on complex
ఆపరేషన్ అండ్ కాంప్లెక్స్ నంబర్స్. ఓకే.
దాని ముందు సమ్ చెప్పారు కదా సార్.
ఒకసారి నేను పెడతాను సో దట్ ఇట్ విల్ బి ఈజీ టు ఐడెంటిఫై. ఆపరేషన్ అండ్ కాంప్లెక్స్ నంబర్స్ చెప్పాం, దానికి ముందు చెప్పిన సమ్ కావాలి. ఓకే, అయితే ఇక్కడ నుంచి It is relation between Cartesian coordinates and polar coordinates. మనం చూసాము. Relation between Cartesian coordinates and polar coordinates is given with z is equal to r cos theta plus r into I sin theta. That we have seen. Whenever coordinates, Cartesian coordinates are given, we can write it polar coordinates. Xy we have already discussed. Xy is the Cartesian coordinate and r theta is the corresponding coordinates are given. We can write the complex number in coordinate points, and if xy coordinate points are given, we can write the polar coordinates r theta. Okay, so and we use simplified notation to write this cos theta plus I sin theta. This cos theta plus I sin theta, we simplify it as cis theta. As we have seen, using cis theta notation is more convenient rather than using cos theta plus I sin theta. So here if you see sin I square is equal to -1. So that cos square theta plus sin square theta is equal to 1. We know that can be written as cos square theta minus I square sin square theta. So that this can be expanded as cos theta plus I sin theta into cos theta minus I sin theta. Into cos A plus B into cos A minus B. A plus B into A minus B is A square minus B square. So here cos square theta minus I square sin square theta, but I square is equal to -1, so that we get cos square plus sin square. So we are writing cos square theta plus sin square theta in different. Now, so here we are writing one as cos theta I sin theta into cos theta minus I sin theta. Okay, students. So we can simply write 1 is equal to cis theta into cos theta minus I sin theta. So that this cos theta minus I sin theta can be written as 1 by cis theta. And cis minus theta, if we see cos theta minus cos of minus theta plus I sin of minus theta, we can write, which is equals to cos minus theta is plus cos theta, so we get it as cos theta, and sin minus theta as minus sin theta, it as minus I sin theta. Therefore cis minus theta is equal to cos theta minus I sin theta, but cos theta minus I sin theta is equals to 1 by cis theta for us. So 1 by cis theta, we get cis minus theta is equal to 1 by cis theta. Again, cis theta is equal to 1 by cis minus theta, we can write. So now this notation, cis theta into cis minus theta, from here if you see, here we have seen cis minus theta as 1 by cis theta, and cis minus theta is equal to cos theta minus I sin theta. That means first part is cis theta, second part is cis minus theta. So product is equals to both each are conjugates to each other. One is the conjugate of the other. Okay, students. So this is all simplification about the theta. So cis theta relations between cis minus theta and cis theta. So this relation should be important. You should understand this relation, as it will be more useful. You are using more in the next chapter. So interchanging between cis theta and cis minus theta. And then since we have discussed, if you require any questions, then we will discuss that particular part. Hope your doubt is clear.
Thank you, sir. Sir,
Yeah, okay.
sir,
I think this is the question I have discussed with her. Yeah, this is the question. 2z minus 3.
Yeah, maybe sir, this one.
Yeah, this is the previous question only. So it is much more simpler. Mod 2z minus 3 is equals to 7. It is easier than the next question. Calculation is also simple. The thing is mod minus 3
Sir, otherwise we can look at it at the last.
Yes, sir. Yes. The simplification part is up to this only they have to use the complex number concept. The remaining part is locus only, what they have done in first year chapter. So if they are not clear with the locus chapter, then they find it difficult to identify. But up to this, it is only simple calculation part.
Okay, sir.
You can take the screenshot and practice so that it will be easy for you. Okay, let us. చెప్పమ్మా.
లోకస్ జెడ్ సమ్ చెప్పారు కదా చెప్పరా?
అవునమ్మా, అవును చెప్పు. లోకస్ ఆఫ్ జెడ్ కావాలా? లోకస్ ఆఫ్ జెడ్ 2 క్వశ్చన్స్ మనం డిస్కస్ చేసాము. లోకస్ ఆఫ్ జెడ్ లోకస్ చాలా క్వశ్చన్స్ మనం డిస్కస్ చేసాము. ఆల్ ఆర్ రిలేటెడ్ విత్ సింప్లిఫికేషన్ ఉంది. ఓకే, so here this is one of the important questions. Locus of z. Finding the locus of z is find the locus of z where z is equal to x plus iy satisfying the given condition. So which is చెప్పమ్మా.
ఈ సమ్ కాదు సార్, బిఫోర్ సమ్ సార్. ఇది అర్థమైంది సార్. అదే
దీని తర్వాత సమ్మా, దీనికన్నా ముందు సమ్మా?
దీని ముందు సమ్ సార్.
దీని ముందు సమ్మా. ఓకే, ఇదా z plus 1 by z plus i?
yes sir.
ఓకే అమ్మా. సో ఇక్కడ మనకి ఏం అడుగుతున్నాడు? రియల్ పార్ట్ ఆఫ్ z plus 1 by z plus i is 1 అని పడిచ్చాడు. రియల్ పార్ట్ ఆఫ్ z plus i by z plus 1 by z plus i is equals to 1. అయితే మరి రియల్ పార్ట్ ఎప్పుడు రాయగలం మనము అంటే, మనకి z plus 1 by z plus i అనేది సమ్ p plus iq or p minus iq ఫామ్ లో ఉండాలి. pq రియల్ నంబర్స్, p belongs to r and q belongs to r. ఈ ఫామ్ లో ఉంటే గనక మనం రియల్ పార్ట్ రాయగలం. వేర్ ద రియల్ పార్ట్ ఈస్ here p. So to identify or to reduce this into p plus iq form, what should be done? Z is equal to x plus iy మనకి ఉంది కదా. z is equal to x plus iy మనకి. So that by replacing z is equal to x plus iy, so we simplify this expression first of all. Z plus 1 by z plus i ని మనము సింప్లిఫై చేస్తున్నాం. సో x plus iy plus 1 by x plus iy plus i ని మనము p plus iq ఫామ్ లో యూస్ చేయాలి. ఎట్లా నేర్చుకున్నాము? బై మల్టిప్లైయింగ్ అండ్ డివైడింగ్ విత్ ది కాంజుగేట్ ఆఫ్ ది డినామినేటర్. సో కాంజుగేట్ ఆఫ్ ది డినామినేటర్ ఏమవుతుంది మనకి ఇక్కడ? నౌ దీన్ని మళ్ళా మనం రియల్ పార్ట్ ఇమాజినరీ పార్ట్ సెపరేట్ చేయాలి. ఇక్కడ చూస్తే దీస్ టు రియల్ పార్ట్, సో దట్ వి రైట్ ఇట్ యాజ్ x plus 1 into x plus 1 plus i into 1. And if you see in the denominator, these two relate to imaginary part. So the denominator becomes x plus y plus 1 into i. Now conjugate of the denominator we take. Conjugate of the denominator we take. So which is x minus y plus 1i. X minus y plus 1i. So that the denominator can be simplified. Denominator can be written as a real number. Now it is all simplification. Numerator and denominator to denominator. Here if you take x into x plus 1, the first part, plus I into xy, minus x plus into y plus 1i. Now multiplying with the first part, x plus 1 into y plus 1i. Again multiplying with the second part, y into y plus i. Here iy into, here you should get as actually plus iy into minus y plus 1i we got. So here if you see minus of what do you here? Minus of iy into y plus 1 into I you get, but I square is equal to minus 1. I into I here we have, so I square is equal to minus 1, so that we get plus y into y plus 1. This is the only thing you might not have identified that I have skipped off because we have discussed in many of the simplifications. So upon simplification, now these two parts relate to real part. Y into y plus 1, x into x plus 1. They are free from I. So that we combine these two. This is x square plus x and the remaining part is y square plus y. So we separate it. And now this if we see is xy plus x plus y plus 1. Okay, students, xy plus x, so y plus 1. Upon removing the brackets, we get minus xy, minus x, minus y, minus 1 will be there. This is missed from the calculation. Minus 1 will be there. So, as we do not require the imaginary part, I did not focus on that. I just ignored, or else simply we will write it as xy minus x plus 1 into y plus 1, we can leave it. We can simply leave it as, instead of simplifying, we do not require this part, so we can leave it as minus of xy minus x plus 1 into y plus 1, we can leave it. We require the real part, so focus on the real part. X square plus x plus y square plus y, the real part is simplified, and the imaginary part is xy minus x plus 1 into y plus 1, so that we get to the real part and imaginary part. If we separate, we will get the real part as x square plus y square plus x plus y by x square plus y plus 1 whole square. And the real part, imaginary part, we can leave it. Here minus 1 should be included, plus 1. Upon simplification, it will comes out to be minus 1. So we do not require the imaginary part. So that I ignored, focusing on imaginary part. So the next part is real part of z plus 1 by z plus I is equals to 1. But we got the real part as x square plus y square plus x plus y by x square plus y plus 1 whole square. So that we will simplify upon cross multiplication and upon simplification we get x plus y minus 2y minus 1 is equal to 0. So that the locus, equation of the locus is x minus y minus 1 is equals to 0. Hope this question is clear to everyone. I just ignored the second part as it is not important. So I ignored the part as well. So you can simply write it as xy minus x plus 1 into y plus 1. You can leave as it is. Hope everything is clear, students.
Sir, mostly there are no more doubts.
Okay, sir. Yeah, the small mistake is rolled over that I did not focus before. That minus 1 I ignored. I forgot to mention.
So I hope we can close the session now.
Yes, sir, we can close the session. As we have another sessions also. 11:30 we have another session to include. Okay, students, thank you very much. Thank you for today's session. And we will meet tomorrow for 2B.